Before we explore this remarkable story, if you appreciate detailed historical accounts that reveal the engineering realities behind World War II aerial combat, please subscribe to our channel and hit the notification bell so you never miss our comprehensive documentaries. In the brutal skies over Europe during 1944, Luftwaffe fighter pilots faced a perplexing tactical problem that was costing German lives at an unsustainable rate. American P-47 Thunderbolt fighters could engage German interceptors on their own terms, deliver devastating attacks with 8 heavy machine guns, and then simply dive away at speeds no German fighter could match, escaping before German pilots could respond effectively. Luftwaffe tactical doctrine emphasized tight-turning combat where German fighters' superior maneuverability could be exploited. But American Thunderbolt pilots refused to fight on those terms, instead using speed and power to dictate combat engagement. When a P-47D made a forced landing in German-controlled France in August 1944 and was captured nearly intact, German test pilots finally received the opportunity to understand what made this massive American fighter so dominant. What they discovered during flight testing shocked every experienced German aviator who witnessed it and forced a fundamental admission that German commanders had resisted. For months, no German interceptor could match the Thunderbolt's ability to dive at 500 miles per hour. And this single performance characteristic made traditional German fighter tactics obsolete against an opponent who could always escape. This is the story of how German pilots flew a captured P-47D, how the revelation of its dive performance capabilities shattered their confidence, and how they came to understand that American design philosophy, emphasizing power and structural strength, had created a fighter that was essentially invulnerable to German interception once its pilot chose to disengage. Before we explore this remarkable story, if you appreciate detailed historical accounts that reveal the engineering realities behind World War II aerial combat, please subscribe to our channel and hit the notification bell so you never miss our comprehensive documentaries. The hot afternoon of August 24, 1944 found Major Heinz Bauer standing on the tarmac at the Reckland test facility north of Berlin, watching with professional interest as ground crews finished reassembling a captured American fighter that would challenge everything he thought he understood about aircraft design and combat tactics. Major Bauer was one of Germany's leading fighter aces with over 200 confirmed victories, a veteran of combat on every front from the Battle of Britain through the Eastern Front and now the defense of the Reich. He had flown virtually every German fighter type in operational service and had evaluated numerous captured Allied aircraft during his career. But even from a distance, the massive American fighter before him looked like nothing he had ever encountered. The Republic P-470 Thunderbolt sat heavily on the ramp, its enormous radial engine cowling giving it a blunt, aggressive appearance that seemed more appropriate for a medium bomber than a fighter. The aircraft dwarfed the Messerschmitt Bf-109 and Focke-Wulf Fw-190 fighters parked nearby, and Burr's first reaction upon seeing it up close was frank disbelief that the Americans considered this enormous machine a fighter aircraft. The P-470 had been captured 3 days earlier when mechanical problems forced the American pilot to make an emergency landing at a Luftwaffe airfield near Beauvais in occupied France. The pilot had attempted to destroy the aircraft with demolition charges before being captured, but alert German guards had intervened before serious damage could be inflicted. The Thunderbolt had sustained some battle damage from the combat that had led to its emergency landing, but German technicians had quickly repaired the damage, and the aircraft was declared flyable. Orders had come down from the highest levels of the Luftwaffe command structure that this captured Thunderbolt was to be transported immediately to Reckland for comprehensive evaluation. German fighter pilots had been reporting for months that P-47s were nearly impossible to intercept once they decided to disengage from combat, diving away at speeds that German fighters could not match. These reports had been met with skepticism by some senior officers who believed they reflected pilot inexperience or poor tactics rather than fundamental aircraft performance differences. Now the Luftwaffe would finally have the opportunity to determine the truth by flying and testing an actual P-47D under controlled conditions. Bauer climbed onto the wing and examined the Thunderbolt's cockpit, and his first impressions reinforced his sense that this was an aircraft built according to completely different design principles than German fighters. The cockpit was spacious and well-appointed with comprehensive instrumentation, excellent visibility through the bubble canopy, and controls that appeared logically arranged and easily accessible. But what struck Bauer most forcefully was the sheer massive structure surrounding the cockpit. The armor plate protecting the pilot was substantially thicker than anything in German fighters. Heavy steel plates that must have weighed hundreds of pounds, but that would stop virtually any caliber of defensive fire. The canopy framework was robust, and the entire fuselage structure visible from the cockpit suggested an aircraft built without Regard for weight savings. Designed for strength and survivability rather than minimal weight and maximum performance. Bauer had spent his entire combat career flying lightweight fighters where every kilogram mattered and where armor protection was minimal because weight was the enemy of performance. The P-47D represented a completely different philosophy, accepting tremendous weight in exchange for protection and structural strength. The evaluation team assembled at Rechlin included some of Germany's most experienced test pilots and aviation engineers. In addition to Major Bauer, the team included Oberst Friedrich Krantz, who had led evaluations of captured Allied aircraft including the B-17 Flying Fortress, and Hauptmann Wolfgang Fischer, who had conducted the detailed examination of captured P-51 Mustangs earlier in the year. The civilian engineering contingent included representatives from Focke-Wulf and Messerschmitt, who were eager to understand how American designers had created a fighter that seemed to violate basic principles of aircraft design that emphasized minimal weight and maximum agility. The team's first task was to conduct a comprehensive ground examination documenting the P-47D's specifications, systems, and construction methods. What they found during this examination provided the context necessary to understand the revelations that would come during flight testing. The P-47D's Pratt & Whitney R2800 double WASP engine immediately commanded attention as the most powerful fighter engine any of the German engineers had examined. The massive 8-cylinder radial displaced 2,804 cubic inches and produced over 2,000 horsepower for takeoff, with power maintained at high altitudes through a sophisticated turbocharger system. The engine weighed approximately 2,350 pounds, more than the empty weight of some German fighters, but it produced power that dwarfed anything available in German fighter aircraft. The ART-2800's construction revealed manufacturing precision and materials quality that impressed the German engineers. Cylinder barrels were precisely machined with finishes that minimized friction, pistons were forged from high-quality aluminum alloys, and the crankshaft was a massive forging that could transmit enormous power without the failures that plagued German engines operating at lower power levels. Every component showed evidence of precision manufacturing and rigorous quality control. The turbocharger system was particularly sophisticated and represented technology that Germany had attempted but never successfully implemented in fighter aircraft. The turbocharger used exhaust gases to spin a turbine that drove a compressor, forcing additional air into the engine at high altitudes where atmospheric pressure was low. This allowed the R2800 to maintain sea-level power output at altitudes exceeding 30,000 feet, giving the P-47D performance at high altitude that German fighters could not match. The turbocharger installation was complex, with extensive ducting to route exhaust gases to the turbine and compressed air to the engine, all packaged within the fuselage in a way that minimized aerodynamic drag while maintaining accessibility for maintenance. German engineers examining the system recognized that it represented years of development and sophisticated manufacturing capabilities. Germany had attempted turbocharger development for fighter engines but had encountered insurmountable problems with turbine materials that couldn't withstand the extreme temperatures and stresses, with ducting that leaked or failed, and with control systems that were unreliable. The American turbocharger worked reliably and gave the P-47D performance advantages at high altitude that made it particularly effective as a bomber escort. The Thunderbolt's armament was overwhelming by any standard. The aircraft carried 8 Browning M2.50 caliber machine guns, 4 in each wing, with approximately 425 rounds per gun for a total of 3,400 rounds of ammunition. This armament weighed over 1,600 pounds including guns and ammunition. Yet the P-47D carried it as standard equipment without apparent performance penalty. The firepower concentration was devastating, with all 8 guns firing simultaneously, producing a weight of fire that could destroy enemy aircraft with brief bursts. German fighters typically carried lighter armament, usually 1 or 2 cannon and 2 machine guns, with total ammunition weights less than half what the P-47D carried. The American approach of carrying massive armament reflected confidence in having enough engine power and structural strength to accept the weight penalty, while German designs minimized armament weight to preserve performance. The structural examination revealed construction methods that explained the P-47D's legendary ruggedness. The fuselage was built around a strong internal framework of heavy forgings and structural members that provided tremendous strength. The skin panels were thicker than those on German fighters and were attached with more fasteners spaced more closely. The wings were built with massive spars and heavy ribs that created structure capable of withstanding loads far exceeding normal flight requirements. Every aspect of the construction suggested that the aircraft was designed to absorb battle, damage, and extreme flight loads without structural failure. German engineers calculated that the P-47D's structural strength probably allowed it to withstand G-forces of 8 or 9 Gs, far exceeding the limits of German fighters that were typically restricted to 6 or 7 Gs. This structural strength had direct combat implications, allowing American pilots to maneuver aggressively at high speeds without fear of structural failure, while German pilots had to be more cautious to avoid exceeding their aircraft's limits. The weight analysis produced numbers that shocked the German evaluation team. The P-47D weighed approximately 10,000 pounds empty, substantially heavier than the loaded weight of a Bf-109G, which was approximately 7,500 pounds fully fueled and armed. With full internal fuel, ammunition, and pilot, the P-47D's combat weight exceeded 14,000 pounds, and with external drop tanks it could weigh over 17,500 pounds. This tremendous weight seemed incompatible with fighter performance according to German design philosophy that emphasized minimal weight as essential for maneuverability and climb performance. Yet intelligence reports and combat experience confirmed that the P-47D was an effective fighter despite its weight. The explanation lay in the tremendous power of the R2800 engine, which gave the heavy Thunderbolt a power-to-weight ratio comparable to lighter German fighters despite the massive weight difference. On August 28, 1944, Major Bauer prepared to conduct the first German evaluation flight of the captured P-47D. He had reviewed the aircraft's operating manual, which had been captured with the aircraft, and had discussed procedures with Luftwaffe intelligence officers who had interrogated captured American P-47 pilots. Bauer understood the basic operating parameters and felt confident he could fly the aircraft safely despite its unfamiliar characteristics. German markings had been hastily painted on the Thunderbolt to prevent German anti-aircraft gunners from shooting it down, and a flight plan had been filed that would keep Bauer well away from any combat zones or areas where Allied fighters might be encountered. As Bauer settled into the cockpit and began his pre-flight checks, he was struck again by how different this aircraft was from anything he had flown. The cockpit was roomy and comfortable, the instrumentation was comprehensive and clearly marked, and the overall impression was of an aircraft designed with careful attention to pilot needs and operational practicality. Bauer started the massive R2800 engine, and the deep rumble that shook the airframe confirmed that this was a power plant of exceptional capability. The engine settled into a smooth idle that demonstrated the precision of its construction and the sophistication of its design. Bauer advanced the throttle for takeoff and felt the Thunderbolt surge forward with authority despite its tremendous weight. The acceleration was impressive, the powerful engine pulling the heavy fighter down the runway with increasing speed until Bauer eased back on the stick and felt the aircraft lift smoothly into the air. The climb performance was good, not exceptional by the standards of lightweight fighters, but certainly adequate for a 14,000-pound aircraft. What impressed Bauer immediately was the stability and solid feel of the controls. The P-47D flew like a much smaller aircraft despite its size, responding predictably to control inputs and maintaining stability without requiring constant attention. Bauer climbed to 20,000 feet and began exploring the P-47D's handling characteristics. The aircraft was responsive and well-mannered, with control forces that were moderate and handling that was predictable throughout the speed range. The visibility from the bubble canopy was excellent, far superior to the framed canopies on German fighters that restricted the pilot's view. Bauer could see in all directions with minimal obstruction, an advantage that would be critical in combat where seeing your opponent first often determined who survived. He put the Thunderbolt through a series of gentle maneuvers, testing its roll rate, pitch response, and general handling. The aircraft performed adequately, though it was not as nimble as the lightweight German fighters Bauer was accustomed to flying. In slow-speed turning fights, the P-47D would be at a disadvantage against Bf-109s or Fw-190s that could turn more tightly and reverse direction more quickly. But Bauer suspected that American pilots had no intention of engaging in slow-speed turning fights, and he was about to discover why. At 25,000 feet, Bauer decided to test the characteristic that German fighter pilots had been reporting with consistent concern, the P-47D's dive performance. He rolled the Thunderbolt inverted and pulled the nose down into a steep dive, advancing the throttle to full power and allowing the aircraft to accelerate. Under the combined force of engine power and gravity, what happened next would change Bauer's understanding of what was possible in a fighter aircraft and would confirm the worst fears of German commanders about the tactical situation they faced. The P-47D accelerated rapidly in the dive, building speed at a rate that exceeded anything Bauer had experienced in German fighters. The airspeed indicator wound past 350 miles per hour, then 400, then 450, speeds that approached the maximum dive limits of Bf-109s and Fw-190s. But the P-47D showed no signs of reaching its limits. The aircraft remained stable and controllable, the controls stayed responsive, and there were no vibrations or buffeting to suggest impending structural failure or control problems. The airspeed continued climbing, 460 miles per hour, 470, 480. Bauer was now diving faster than any German fighter could safely dive, yet the P-47D felt solid and controllable with no indication of stress or instability. The dive continued and the speed kept building. 490 miles per hour, 495, and then the airspeed indicator touched 500 miles per hour, a speed that seemed impossible for a fighter aircraft, yet was clearly being achieved by this massive American machine. Bauer pulled back on the stick to begin recovery from the dive, and the P-47D responded smoothly despite the tremendous forces involved. The aircraft pulled out of the dive in a long arc, the structural strength absorbing G-forces that would have torn the wings off a German fighter, and Bauer found himself climbing back toward altitude with speed still exceeding 400 miles per hour. The entire experience had lasted perhaps 30 seconds, but it had revealed a performance capability that fundamentally changed the tactical equation in air combat. Bauer climbed back to altitude and repeated the dive test, this time monitoring his instruments more carefully and noting the P-47D's behavior throughout the speed range. The results were consistent. The Thunderbolt could dive at speeds exceeding 500 miles per hour while remaining stable, controllable, and structurally sound. Bauer had never experienced anything like this in German fighters, which became increasingly difficult to control as speeds approached 450 miles per hour, and which risked structural failure if pushed beyond their limits. The P-47D seemed to have almost unlimited dive capability, limited more by the pilot's courage and the airspeed indicator's range than by any inherent aircraft limitation. After 90 minutes of flight testing, Bauer returned to Rechlin and landed the P-47D. His debriefing would send shockwaves through the Luftwaffe command structure and force admissions that some senior officers had been reluctant to make. Burr's report was direct and unambiguous. He stated that the P-47D Thunderbolt could dive at speeds exceeding 500 miles per hour while remaining fully controllable and structurally sound. No German fighter could match this performance. The Bf-109G was limited to approximately 450 miles per hour in dives, before control problems became severe and structural failure became likely. The FW-19OA could dive slightly faster, perhaps to 470 miles per hour under ideal conditions. But this approached its structural limits and pilots were warned not to exceed these speeds. The P-47D's ability to dive 50 to 100 miles per hour faster than German fighters meant that American pilots could always escape from combat simply by pushing over into a dive and using their tremendous power and structural strength to accelerate beyond any speed German fighters could match. A German pilot attempting to follow a diving P-47D would quickly reach his aircraft's limits and would be forced to reduce his dive angle or pull out entirely, allowing the American to escape. The tactical implications were devastating for German air defense efforts. If P-47D pilots could always escape by diving, then German fighters could only engage Thunderbolts when they held overwhelming positional advantage that would allow them to destroy the American aircraft before it could initiate a dive. This required German fighters to have significant altitude advantage and to achieve surprise, conditions that were increasingly difficult to obtain as American fighter tactics improved and as numerical superiority allowed Americans to maintain combat air patrols at various altitudes. More fundamentally, the dive performance disparity meant that combat occurred on American terms, with P-47D pilots choosing when to engage based on tactical advantage and disengaging whenever the situation became unfavorable. German fighters had no equivalent capability. They could not escape from aggressive American fighters and were forced to accept combat even when disadvantaged. The evaluation team conducted additional flights with different pilots to confirm Burr's findings and to explore other aspects of P-47D performance. Every test pilot who flew the Thunderbolt reached similar conclusions about its dive capability. Hauptmann Fischer, who had extensive experience evaluating captured American aircraft, stated that the P-47D's dive performance was the most significant single characteristic he had encountered in any Allied fighter. The ability to dive at 500 miles per hour rendered conventional German interception tactics largely ineffective, as they relied on catching enemy fighters and forcing them into turning combat where German maneuverability advantages could be exploited. An opponent who could simply dive away faster than German fighters could follow could not be caught unless he made tactical errors. The German pilots conducted mock combat exercises between the captured P-47D and German fighters to understand how the aircraft would perform in actual engagement. The exercise took place on September 5, 1944, at altitude over Rechlin. Bauer flew the P-47D while an experienced Luftwaffe pilot flew a Bf-109G-14. one of the latest variants with improved performance. The rules of engagement called for the aircraft to start at equal altitude and speed, then engage in simulated combat with each pilot attempting to achieve firing positions while avoiding being fired upon. The results confirmed what the dive tests had suggested. In turning combat at moderate speeds, the Bf-109 could outturn the P-47D and could achieve firing positions through superior maneuverability. But the moment Boré recognized he was in a disadvantageous position, he simply pushed over into a dive and accelerated away. The Bf-109 pilot attempted to follow but quickly reached his aircraft's maximum safe dive speed while the P-47D continued accelerating and opened the range rapidly. Within seconds, the P-47D had opened a gap of several thousand yards and was climbing back to altitude using its superior power while the Bf-109 pilot struggled to close the distance. The exercise was repeated multiple times with the same results. If the P-47D pilot fought intelligently and used his aircraft's strengths, the German fighter could not force a decisive engagement. The Thunderbolt could make high-speed slashing attacks from advantageous positions, firing its 8.50 caliber guns in brief bursts, then diving away before the German fighter could respond effectively. The only scenarios where the German fighter consistently won were when the P-470 pilot made serious tactical errors like allowing himself to be caught at low speed and low altitude where diving away was not an option. But competent American pilots would never place themselves in such positions. The mock combat confirmed that the P-470's dive performance gave it a tactical invulnerability that German fighters could not overcome through maneuverability or pilot skill alone. The engineering analysis focused on understanding why the P-470 could dive so much faster than German fighters. The answer lay in the combination of several factors that German designers had not integrated into their aircraft. First, the P-470's tremendous weight actually became an advantage in dives. As gravity accelerated the heavy aircraft rapidly, and its massive engine could contribute additional thrust to further increase dive speed. German fighters were lighter and had less gravitational acceleration in dives. Second, the P-470's structure was massively strong, built to withstand the aerodynamic loads and G-forces encountered during high-speed dives and pullouts. German fighters had lighter structures optimized for maneuverability that reached their stress limits at lower speeds. Third, the P-470's control surfaces remained effective at high speeds due to careful aerodynamic design and robust construction. German fighters often experienced control stiffening or flutter at high speeds that made them difficult or impossible to control safely. Fourth, the P-470's engine could provide full power throughout the dive, maintaining thrust that helped accelerate the aircraft. German engines sometimes experienced problems at very high speeds due to ram air effects on carburation or cooling. Finally, the P-470's design had been validated through extensive testing, including actual high-speed dives during development, ensuring that no unexpected problems would emerge when pilots pushed the aircraft to extreme speeds. German fighters had received less comprehensive testing due to time and resource constraints, and safe operating limits were often conservative estimates rather than empirically validated boundaries. The cumulative effect of these design and development differences was that the P-470 could safely operate in flight regimes that were dangerous or impossible for German fighters. The captured P-470 evaluation also examined other performance characteristics and systems. The turbocharger system was tested at various altitudes, confirming that the aircraft maintained excellent performance well above 30,000 feet where German fighters were struggling. The Bf-109G's performance declined significantly above 25,000 feet as its single-stage supercharger lost effectiveness. The P-470 could fight effectively at 35,000 feet or higher, giving it the option of holding altitude advantage that German fighters could not contest. This high-altitude capability was particularly important for bomber escort missions where American heavy bombers operated at altitudes around 25,000 to 30,000 feet. P-470s could patrol above the bomber formations and dive down on German interceptors attempting to attack the bombers, using their altitude and speed advantages to disrupt German attacks. The fuel capacity and range testing revealed another P-470 advantage that German fighters could not match. With internal fuel alone, the P-470 had endurance of approximately 2 to 2.5 hours, depending on power settings and altitude. With external drop tanks, endurance could exceed 4 hours, allowing escort missions deep into Germany. German fighters had endurance of approximately 1 to 1.5 hours, severely limiting their operational flexibility. German fighters scrambling to intercept American formations had to climb to altitude quickly, locate and engage the enemy, and return to base before running out of fuel. The time available for actual combat was limited, often just 20 to 30 minutes. P-470 pilots could patrol for extended periods. had ample fuel for combat maneuvering, and could pursue German fighters that attempted to escape. The endurance disparity meant that Americans could maintain continuous fighter presence over German territory, while German fighters could only operate for brief periods before requiring refueling. The armament effectiveness was evaluated through examination of the 8.50 caliber installation and analysis of the weight of fire it could deliver. German engineers calculated that the P-47D firing all 8 guns simultaneously would deliver approximately 100 pounds of projectiles per minute at the target, a weight of fire that exceeded most German fighters by factors of 2 or 3. The .50 caliber rounds were heavy enough to penetrate armor and structure effectively, and the high rate of fire meant that even brief bursts could cause catastrophic damage. The ammunition capacity of 3,400 rounds total meant that pilots could fire for approximately 25 seconds of sustained fire if using all guns continuously, or could make dozens of shorter bursts during typical combat operations. German fighters with limited ammunition often ran out after just a few attack passes, leaving them defensively armed only while American fighters still had plenty of ammunition remaining. The oxygen system, environmental controls, and pilot comfort features in the P-47D were examined and compared to German fighters. The Germans found that the American aircraft provided better crew comfort at high altitude with more effective heating, superior oxygen delivery, and generally better attention to human factors. German pilots routinely suffered from cold and hypoxia during high-altitude operations because equipment was inadequate or unreliable. American pilots in P-47Ds could operate comfortably at extreme altitudes for extended periods, maintaining full cognitive function and physical capability throughout long missions. This seemingly minor difference in crew comfort had significant combat implications, as pilots who were comfortable and alert were more effective than pilots who were cold, hypoxic, and fatigued. The comprehensive evaluation report compiled by the Reckland team was distributed to Luftwaffe Command, fighter unit commanders, and aircraft manufacturers. The report's conclusions were unambiguous and deeply disturbing for German air defense planning. The P-47D Thunderbolt represented a fighter design optimized for characteristics that gave it decisive tactical advantages over German fighters. Its ability to dive at 500 miles per hour meant it could always escape from German interceptors, rendering conventional pursuit tactics ineffective. Its high-altitude performance through turbocharger-equipped engine meant it could operate where German fighters were ineffective. Its long range meant it could escort bombers throughout their missions and could pursue German fighters relentlessly. Its heavy armament meant it could destroy German aircraft with brief bursts. Its structural strength meant it could absorb battle damage that would destroy German fighters and could maneuver aggressively without risk of structural failure. The report made tactical recommendations for German pilots engaging P-47Ds, though the recommendations essentially acknowledged that German fighters were at fundamental disadvantage. German pilots were advised to avoid diving after P-47Ds as they could not match the American aircraft's dive speed, and attempting to do so would put them in positions where they could not maneuver or defend themselves. Instead, German pilots should attempt to force P-47s into climbing fights at altitudes above 30,000 feet where the turbocharger advantage was less significant, though this was difficult to accomplish if American pilots flew intelligently. German pilots should attack only when holding significant altitude advantage and only when they could achieve surprise, allowing them to destroy American aircraft before they could react. If P-47s initiated dives to escape, German pilots should not pursue, but should climb back to altitude and reposition for possible future attacks. These recommendations essentially conceded that German fighters could only engage P-47Ds under ideal circumstances that would be rare in actual combat, and that American pilots who flew competently could avoid being shot down by refusing unfavorable engagements. The psychological impact of these conclusions on German fighter pilots was significant and contributed to declining morale and effectiveness. Pilots understood that they were flying inferior aircraft against opponents who held multiple advantages and who could escape whenever threatened. This knowledge made pilots cautious and defensive, reducing their aggressiveness and combat effectiveness. Some pilots became fatalistic, understanding that survival was largely a matter of luck rather than skill when facing P-47s that could always disengage. German aircraft manufacturers attempted to develop improved fighters based on lessons from the P-47D evaluation, but the fundamental problem remained that Germany lacked the industrial capacity and resources to build comparable aircraft. The Ta-152, an advanced high-altitude fighter developed by Kurt Tank, incorporated some lessons about the importance of high-altitude performance and structural strength, but production numbers were minimal, and the aircraft entered service too late to affect the war's outcome. Jet fighters like the Mi-262 offered performance advantages over piston-engine aircraft, including the P-47D, But jet production was limited by engine reliability problems, fuel shortages, and Allied bombing of production facilities. Most German pilots continued flying Bf-109s and Fw-190s that were incrementally improved, but that could not match American fighters in key performance characteristics. The dive performance revelation became widely known among German fighter pilots through informal communication networks, and 500 miles per hour became a shorthand reference for the fundamental performance gap between German and American fighters. Pilots discussing combat experiences would note that P-47s had gone to 500 to escape, meaning they had dived away at speeds German fighters could not match. The phrase carried connotations of frustration and resignation, acknowledging a tactical reality that could not be overcome through courage or skill. Some pilots reported that American P-47 pilots seemed to taunt Germans by pulling up after diving away and waggling their wings, a gesture suggesting they knew they were invulnerable and could toy with German fighters who could not catch them. Major Bauer continued serving as a test pilot and operational fighter pilot throughout the remaining war period, though his experiences with the captured P-47D had given him sobering perspective on Germany's situation. He later stated that flying the Thunderbolt had been one of the most educational and depressing experiences of his career. The aircraft performed better than he had expected despite its tremendous weight, and its dive performance was simply in a different class from anything German. Bauer noted that the P-47D embodied American strengths in industrial capacity and engineering sophistication, representing not just good design but the ability to manufacture powerful engines, build strong structures, and develop sophisticated systems that worked reliably. Germany could no longer match these capabilities if it ever could. The P-47D evaluation influenced German understanding of American fighter development more broadly. German intelligence recognized that if the Americans could build fighters as capable as the P-47D, the reports about other American aircraft like the P-51 Mustang were probably accurate as well. The pattern was clear. American fighters were getting progressively better through continuous development, generous funding, and industrial capacity that could implement improvements rapidly. German fighters were being improved incrementally, but the improvements could not close the widening performance gap. By late 1944, American fighters dominated German skies, shooting down German aircraft at rates approaching 5 or 10 to 1, while German fighters struggled to inflict meaningful casualties on American bomber formations and their escorts. The post-war period brought additional perspective on the P-47D and its significance. Over 15,000 Thunderbolts were produced during the war, making it one of the most numerous American fighters. The aircraft served throughout the European and Pacific theaters, achieving excellent combat records in both fighter-to-fighter combat and ground attack roles. The P-47's ruggedness and firepower made it particularly effective in ground attack, where its ability to absorb ground fire and deliver heavy ordnance made it devastating against enemy ground forces. The dive performance the German pilots had found so impressive served American pilots well throughout varied combat operations, providing an escape option that saved countless lives and allowed aggressive tactics. German pilots and engineers who survived the war were extensively debriefed about their experiences with captured American aircraft. Major Bauer provided detailed testimony about the P-47D evaluation and its implications. He stated that the 500-mile-per-hour dive capability represented the single most significant performance characteristic he had encountered in any Allied fighter because it provided tactical invulnerability that negated all German performance advantages. A fighter that could always escape could never be defeated by superior tactics or marksmanship. It could only be destroyed through its pilot's errors. Competent P-47D pilots who flew intelligently were essentially unkillable by German fighters, and this reality had profound effects on combat outcomes and German morale. The engineers who examined the P-47D's structure and systems provided technical analysis that confirmed American manufacturing superiority. The precision of construction, quality of materials, and sophistication of systems like the turbocharger all reflected industrial capabilities that Germany could not match. German industry was struggling to maintain production of existing fighter types with declining quality as resources were exhausted and as Allied bombing destroyed factories and transportation infrastructure. The idea of developing and producing new fighters, incorporating lessons from the P-47D evaluation, was simply unrealistic given Germany's situation by late 1944. One particularly poignant aspect of the P-47D evaluation was recognizing how the American design philosophy differed fundamentally from German approaches. German fighters emphasized lightweight construction and maximum maneuverability, accepting minimal protection and limited systems to achieve low weight. This philosophy had served well early in the war when German fighters faced opponents with similar or inferior performance and when combat often occurred at lower altitudes where maneuverability was paramount. But as the war progressed and combat occurred increasingly at high altitudes where power and structural strength mattered more than low weight, the German design philosophy became a liability. The Americans had recognized earlier that modern air combat required fighters with overwhelming power, robust structures, heavy armament, and long range. They had accepted the weight penalties associated with these characteristics and had built engines powerful enough to achieve good performance despite heavy weights. The result was fighters like the P-47D that could dominate combat through speed, power, and structural strength, rather than through lightweight agility. German designers had recognized these principles intellectually but had lacked the industrial capacity to implement them. Building 2,000 horsepower engines required manufacturing capabilities Germany did not possess. Creating structures strong enough for 500-mile-per-hour dives required materials and engineering that Germany could not provide. Accepting 14,000-pound combat weights required confidence in having adequate power. Confidence Germany could not justify given its engine limitations. The P-47D represented what was possible when design philosophy matched industrial capability. And Germany had neither the philosophy nor the capability by 1944. The story of German pilots flying the captured P-47D and admitting that no German Interceptor could match its 500-mile-per-hour dive capability illuminates the technological and industrial competition that ultimately determined World War II's aerial combat outcomes. The specific number, 500 miles per hour, became symbolic of the performance gap that had opened between German and American fighters. That speed represented the difference between aircraft designed for maneuverability versus aircraft designed for power and speed. It represented the difference between accepting weight for strength versus minimizing weight for agility. It represented the difference between industrial capacity that could build massive, powerful engines versus industry struggling to maintain production of smaller, less capable engines. Most fundamentally, it represented the tactical reality that American fighters could engage on their terms and escape when threatened, while German fighters were forced to accept combat even when disadvantaged. The admission forced upon German pilots and commanders by the P-47D evaluation was painful but necessary. It confirmed what combat statistics had been suggesting for months. German fighters were outclassed by American aircraft in characteristics that mattered for modern air combat. The recognition came too late to change development priorities or industrial allocation in ways that might have narrowed the gap, but it provided honest assessment of reality that was essential for tactical planning. German fighter pilots who understood they faced opponents with superior dive performance could avoid futile pursuit and could focus on the limited circumstances where they might achieve success. This realistic assessment probably saved German lives, even as it confirmed that the strategic situation was hopeless. As we conclude this comprehensive examination of what German pilots discovered when they flew a captured P-47D, Thunderbolton admitted that no German interceptor could match its 500-mile-per-hour dive capability. Several themes emerge clearly. First, specific performance characteristics, like dive speed, can have disproportionate tactical significance by enabling or denying fundamental combat options, like escape from unfavorable engagements. Second, design philosophy choices about whether to prioritize lightweight agility versus power and structural strength reflect assumptions about what air combat requires, and those assumptions determine whether resulting aircraft are effective under actual combat conditions. Third, industrial capability sets limits on what design philosophies can actually be implemented, and nations with superior manufacturing capacity can build aircraft that nations with limited capacity cannot match, regardless of theoretical knowledge. Finally, honest assessment of enemy capabilities and one's own limitations is essential for realistic tactical planning and strategic decision-making, even when that assessment reveals uncomfortable truths. The Republic P-47 Thunderbolt earned its place in aviation history as one of World War II's finest fighters, achieving remarkable combat success through performance characteristics that included exceptional dive capability, high-altitude effectiveness, heavy armament, robust construction, and long range. The 500-mile-per-hour dive speed that shocked German test pilots represented not just impressive performance but a comprehensive design approach that prioritized characteristics proven essential in modern air combat. German pilots who encountered P-47Ds in battle and who later flew captured examples understood that they faced an opponent designed and built according to principles their own nation could no longer match. Thank you for watching this detailed exploration of one of World War II's most significant fighter aircraft evaluations and the shocking revelation it provided about performance capabilities German fighters could not match. If you found this comprehensive examination of the P-47 Thunderbolt and its impact on aerial combat valuable and engaging, please subscribe to our channel for more in-depth documentaries that reveal the engineering realities and tactical implications behind historical events. Share this video with others who appreciate military aviation history that goes beyond surface-level descriptions to examine the technical details and human experiences that shaped outcomes. Leave your thoughts and reflections in the comments below. As we value our community's engagement with these detailed narratives, your support enables us to continue producing these thorough investigations into military technology and its profound impact on warfare. Until next time, this is the story of how a captured American fighter revealed through its 500-mile-per-hour dive capability that German interceptors could not match the performance of an opponent that could always escape, and how that single characteristic symbolized the broader technological and industrial advantages that determined aerial supremacy in the skies over Europe.